Okay, so here we go. We're fixing to start on 3.1 through 3.4. Okay, 3.1 through 3.4. Most of this stuff is going to be a review. 3.1 we're going to do today. 3.2 we'll do tomorrow. 3.1 you already know how to do. 3.2 won't be bad. 3.3 will be easy. 3.4 will probably be the most difficult of them. Since that little 50-point test is on Thursday, I think this is probably going to push this test to Tuesday, Wednesday. Okay, I'd like to do it Monday, Tuesday, but I don't think that's going to happen, especially with the 3.4. I want you to know how to do 3.4, because if you don't learn how to do 3.4, it's going to affect the rest of this chapter. All right, so Tuesday and Wednesday. All right, so today, 3.1, we are going to be solving systems by graphing. Okay, solving systems of equations by graphing. So we're going to work this first one, and y'all are going to go, oh, I remember this. We did this in Algebra 1. Yes, you did. It's an Algebra 1 skill. I'm going to add a little bit to it, but not too much. Okay, so here we go. Example 1. Your system, this is the way I like to write a system because it tells me that they go together. I don't put a brace on the other side, I just put it on one side. Okay? Some books just write them and tell you that they're systems. Back in the olden days, they always wrote them like this, so this is the way I tend to write them. So my first equation is 4x plus y is equal to 8. My second equation, 2x minus 3y is equal to 18. So we're going to solve it by graphing. On your worksheet in your test, they are going to give you a coordinate plane. So I don't have one now, so I'm just going to mark one off. If you don't mark it off carefully, you won't be able to tell what the answer is, okay? And it won't work in the right spot. Most of the graphs on the test and the worksheet are those standard 10 by 10 graphs. Okay, so there he is. So all I'm going to do is graph these two lines, and then what am I looking for? Where they what?
Intersect.
Yeah, where they intersect. That's all you're going to find. Okay, so this should not be hard. Do you agree? Should you know how to graph a line?
Yes.
Yes. You've got to learn how to graph a line. All right? Could I take a calculator away from you and still expect you to be able to do this?
Yes.
Yes. Okay? Probably will. All right? But I want you to use your calculator on your worksheet because I'm going to show you something. I want you to practice on it. Okay? A skill that will pop up later on. Okay, so here's the first equation. 4x plus y equals 8. All right? So I'm going to graph it. Tell me what to do.
Minus 4.
Yeah. Minus 4x from both sides. So now I get y is equal to, who goes first?
Negative 4x.
Yeah, negative 4x goes first, and then plus 8. Because now he's in slope-intercept form. Do you agree? Y equals mx plus b is called slope-intercept form. Because you can look at it and tell what the slope and the y-intercept are. What's the slope?
Negative 4.
Negative 4. What's my y-intercept?
8.
8. Okay, so I'm going to go ahead and graph him while he's on my mind. All right, my y-intercept is 8, so I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8. Make a mark. And then I'm going to use my slope at negative 4. Now listen to me. Should we all have approximately the same points on our graph? Okay? People, how many dots do you have to have on a line?
3.
I asked you to put 3. Okay? So we all should have 3 dots, and they really should be the same. Some people might go up and to the left instead of going down and to the right. Okay? But they should be centered around this guy right here. So I'm going to go down 4, 1, 2, 3, 4, because it's negative, and right 1, and I'm going to make a dot. And then I'm going to go down 4, 1, 2, 3, 4, and to the right 1 and make a dot. I'm going to do it one more time since I'm looking for an intersection. 1, 2, 3, 4, and to the right 1. So this is my line. Now I'm going to graph this other guy. I'm going to graph 2x minus 3y equals 18. Okay, so tell me what to do first. Minus 2x. We're solving for y. We're putting it in slope-intercept form. Minus 3y is equal to negative 2x goes first plus 18. And now what do I do? Divide by negative 3. Who gets divided by negative 3? Everybody, because we have to be fair, right? So we're going to divide this side by negative 3 and this side by negative 3. So y is equal to, what's a negative divided by negative?
Positive.
And that's 2/3, right? X. What is a positive divided by negative?
Negative.
And 18 divided by 3 is 6. What's my slope?
2 over 3.
2 over 3. What's my y-intercept?
6. Negative 6.
Negative 6. So I go down to negative 6. 1, 2, 3, 4, 5, 6. And I use my slope, which is 2/3. So I go up 2 and over 1, 2, 3. What? Look at there. That's perfect. Up 2 and over 1, 2, 3. So here is my line. Okay? Now, what do we think is this point? 1, 2, 3, and 1, 2, 3, 4. I think it's 3, negative 4. Do you? That's what it looks like. Okay? So, this is what I want you to do. I want you to write what it is right there, but I want you to find it on your calculator. Okay? I want you to write what it is right here. Am I setting the example of what I want to see on your worksheet? Yes. I want to see this work right here, and then I want to see your graph, and I want to see the point written down. But I want you to find the point on here. Okay? So, I'm going to turn my calculator on. I'm going to show you what my calculator looks like when I first turned it on. It had some big equation right there, I don't know. Okay, so it had a big equation right here, so I cleared it out. And then, y'all, if you have a plot turned on and we're just trying to graph something like this, that's going to mess me up. All right? So just arrow up on top of it and press enter, and that will turn it off. Okay? So we're going to go down here. Here's my first equation right here, negative 4x plus 8. So, negative 4x plus 8. Enter. Here's my second equation, 2/3 x minus 6. You can use the fraction button. I don't like to use the fraction button. You don't have to put this in parentheses, but here's what I say. If you don't know when you have to put it in parentheses and when you don't, then you better put it in parentheses always, okay? So I try to set that example for y'all. So 2/3 x minus 6. Now, I'm going to go zoom 6, which is a standard 10 by 10 graph. That's kind of what I drew. It's what yours is going to look like on your thing. I wanted to see if mine looks like it's supposed to look. So I'll press 6. Don't arrow down, just press the 6. Hey, look at there. Does mine look just like that? Very good. Okay, so now I want to find that point right there. So do I just press trace and kind of guess where it might be? No. No. I made my calculator find it, right? So I go second and calculate. That's above the trace. Second and calculate. What do I want him to calculate?
5.
Yeah, number 5, the intersection. So just press the 5, people. Now look what he's doing. He's asking me questions. Okay? So do you see my spider right there? He's jumping up and down. And he's hollering, hey, lady, is this your first curve? And there's my equation right there. So it gives me the equation. He's showing it to me, and he's asking me this question. Is that my first curve? Yes, it is. So I'll press enter. Now he jumps down here on the second one, and he's jumping up and down. There's my equation. And he's saying, hey, lady, is this your second curve? Yes. Why, yes. So I press enter. This is how I know it's a guy. Because what does he want to do now? Oh, do you want to play a game? You want to guess? No, I don't want to play a game. So I'll press enter. Bam. It tells me what the answer is, and it is 3, negative 4. Okay? Anybody got a question? No questions? Okay, so on your worksheet, this is what I want to see. It's going to give you a system, and it's going to give you a graph. somewhere on that worksheet, not big as a first grader, can you write? No. You cannot write big as a first grader. You have to write small. I want you to solve for y. You don't have to show all this work. Most of y'all just move that over, change the sign, divide, okay? So, and then graph, and then find this on the calculator and write it down. Anybody got a question? Okay, so let's learn some different stuff. Okay, so let's talk about some thought things. My equation is going to be in y equals mx plus b form, right? Okay, tell me one possible way that those lines, what they could do on a coordinate plane. Tell me one thing they could do. Like, what did those do? Could they, like, one thing they could do is they could intersect in one point. Do you agree with that? One solution. That's the one we had, right? That's what these guys did right here. They intersected in one point. Are they ever going to intersect again? No. No. So they intersect in one point. They have one solution. Okay? What else could they do? What else could two lines do on a coordinate plane? What? They could be parallel. And then how many solutions would they have? Zero. Okay? So they could be like this, and then they will have no solutions. Alright? So we just talked about all the possible things that could happen. They could intersect one time, they could intersect no times. Okay? They have no solutions. They have no points in common. There is not a point that will satisfy this equation and this equation. Okay? This is the only point that will satisfy both of those equations. Alright? That's another way to check. You can plug it back in. It has to satisfy both of them. Alright? What about this? What's another way? One more way. Yeah, they could be right smack dab on top of each other. So here's one of them, and here's the other one. I'll make him in a highlighter, okay? So he goes like this, right on top of that guy, okay? So how many solutions do they have? Yeah, they have an infinite number of solutions, okay? An infinite number of solutions. All right, so there's names for these things, all right? There's mathematical, technical names. So that's what I want to talk about. I want to leave a little bit of space because we're going to come back and we're going to talk about what these things represent, okay? And their names. But before I talk about their names, let's talk about each one of these. Let's talk about these two right here. Tell me, if both these lines are in y equals mx plus b form, tell me what you know about these slopes. If these two lines intersect in one place, tell me what you know about their slopes. Could they both be positive?
No.
So, like, they couldn't look like this?
Yeah.
Aren't those both positive? And they still got a point. So, they're not one negative and one positive, but what about them? No? You don't know anything? Okay, so what about these guys' slopes? Their slopes are the same. What about their y-intercepts? Do we care about them? Could they be the same? Why not? Yeah, Austin said they could be the same because then they'll be on the same, they'll be right the same thing. That's this right here. So do I care about their y-intercepts? Yes, I do. What do you know about them? They're different. Guess what? B1 is not equal to B2. They can't be the same. The slopes are the same, but the y-intercepts can't be the same. That's what scoots one up and one down. One makes one below and one above. Okay? What about this guy right here?
It's the same everything.
Okay, same slope and what? Same y-intercept. People, it's the same stinking line. Okay? Same slope, same y-intercept. Now tell me what you know about these guys.
Not the same.
Aren't the same what? Slopes. That's exactly right. Here, y'all, my slopes are not equal. These slopes are different. When two slopes are different, that means those lines will intersect somewhere. Okay? What about their y-intercepts? Do I care about their y-intercepts? No, don't care at all. Could they be the same? If they were, that would be the one point that they had in common. Do you understand what I'm saying? Okay? If they're not the same, it doesn't matter. I don't care about B. All I care is if the slopes are different, I have one solution. All right? Are you with me? Okay. So, are y'all awake?
No. I'm awake.
Y'all obviously did not get any sleep this weekend. Okay? So, some of y'all are over there just like your eyes are doing this.
We should have done this.
That's miserable. So take about 3 deep breaths, okay, and get you some oxygen flowing. Okay, so I'm going to tell you 2 names that these are called. And I'm not even going to tell you what their definition is. I'm just going to tell you the definitions and you decide who goes with who. Because I want you to understand that math is logical. You're going to pick the right one just because the knowledge that you have. Okay? So here's one thing that I'm trying to tell you also. When you're taking a test, most of the time, your first gut instinct answer is the right one. Unless you absolutely, positively know without a doubt that you made a mistake, don't go change your first answer. You understand what I'm saying? When you're making a guess, an educated guess, your gut instinct is what you go with. Don't change that answer because that will mess you up. Okay? Don't second guess yourself. All right, so here are the 2 words. One is consistent. Consistent. And one is inconsistent. Okay? Consistent and inconsistent. Okay, so here it is. One of these means has a solution, and one means does not have a solution. Okay? One means has a solution, and one means has no solution. So which one of these words means has no solution? See? No solution. So that means consistent must mean what? Has a solution. Okay? So let's go over here. Let's go up here, all right? And let's name them. Now look, consistent means it has a solution. Inconsistent means it has no solution. So what would you call this guy right here? Consistent. What would you call this guy right here? Inconsistent. He has no solution. What would you call this guy right here? Consistent. Now he has not just a solution, good night. He has an infinite number of solutions. Okay, so I don't like this. Like this is consistent and this is consistent, but is there a difference between these 2?
Yes.
Yes. People, is there a difference between having one solution and an infinite number of solutions? Well, I don't know. Is there a difference between having $1 and an infinite number of dollars? Going to work tomorrow, sitting on the patio drinking my coffee. Okay? Do you understand? There's a huge difference. So we need to differentiate between these 2 right here. Okay? So I'm going to tell you what the words are that differentiate between those. Okay? So the words are dependent and independent. Dependent and independent. All right? So now this guy, he's just inconsistent. He's not inconsistent in anything else. You're inconsistent, you have no solutions. Okay? So, but there's a difference between these 2. All right? So dependent. Dependent means what one does depends on what the other one does, right? Do you see what I'm saying? This one says what one does has nothing to do with what the other one does. All right? So, this one right here. What do you think he is? One line on top of the other one. Do you think he's dependent or independent?
Independent.
Why is he dependent? Because what he does, what? Depends on what the other one's doing, because they're doing what? The same thing. So whatever this guy does, the yellow guy's got to do it too. Okay? So dependent means infinite solutions. It's the same line, guys. What one does, the other one does. They are dependent on each other. So independent has how many solutions?
One.
One solution. What one line does? Has nothing to do with the other line. Okay, M1 not equal to M2. That's what's making them have one solution. Their slopes are not equal to each other. All right, anybody got a question? Okay, so let's go back up here. Consistent and what? Independent. They are two independent lines doing different things. Independent. I hope to raise my children to be independent of me. Okay? So, they have their own bills and their own stuff. What about this guy?
Dependent.
Very good. So, consistent and dependent. What one line does depends on what the other one does because they're doing the same thing. Okay? All right, let's work one problem. Then we're through. Example 2. See, this is pretty easy, isn't it?
Yeah.
Okay. So, tomorrow we're going to do solving systems by elimination and substitution. Y'all remember that? You did it in Algebra 1. Okay? I'm going to teach it to you again, so if you don't, it'll be okay. So, consistent and independent. Consistent and dependent, or inconsistent. Okay? I want to know. I'm going to give you a system, and I want to know which one of these it is. Now, y'all listen to me. One time we had a multiple choice test, and one of this was a choice, this was a choice, this was a choice, and then it had another choice, because you know it goes A, B, C, or D, and it said inconsistent and independent. People, is that even a choice?
No.
No, that's not, we never even talked about that. Okay, they like just had to make up something, so they made up something. All right, so you knew it wouldn't be that one. All right, so here's my system. 4x plus 3y equals 8, and 8x minus 6y equals 16. Okay, now to know which one it is, do I have to graph it? No. I mean, we looked right here and we said, oh, if the slopes are different, this is what it is. If the slopes are the same and the y-intercepts are different, this is what it is. If the slopes are the same and the y-intercepts are the same, this is what it is. Okay? Now, if you like them going with the graphs, then you could graph it. Okay? So, I'm going to take each one of these equations and I'm going to solve for y. So, here's the first one. 4x plus 3y equals 8. Are you with me? So, I'm going to subtract 4x from both sides, right? Or move it over to the right and change its sign. Whatever you think. Negative 4x plus 8. Are you with me? Now what do? Divide by 3. Everybody gets divided by 3. So y is equal to negative 4/3 x plus 8/3. What's my slope? Negative 4/3. What's my y-intercept? 8 over 3. Okay? So now we'll go look at this next guy. 8x minus 6y equals 16. Y'all, even if I were graphing it, this is what I would want to see. Do you understand that? Okay. So, negative 6y is equal to, move that 8x over here and it becomes negative 8x plus 16. Now what do? Divide by negative 6. And y is equal to, what's a negative over a negative?
Positive.
Positive. What does 8/6 reduce down to? 4/3. You've got to put your fractions in lowest terms, okay? What's a positive divided by a negative?
Negative.
And what does 16/6 reduce down to?
8/3.
8/3. So what's my slope? 4/3. What's my y-intercept?
Negative 8/3.
Negative 8/3. Look at my slopes. Are they the same? No. They're not the same. Okay? I don't care that one's negative and one's positive and they're close to being the same. Okay? They're not the same. What's my answer? Consistent and independent. There you go. All right. Anybody got a question? Everybody okay? All right. So tomorrow we'll do 3.2. Wednesday we'll do 3.3. Thursday we'll take a little test, and we'll start on 3.4. And then Friday we may test on Monday, Tuesday, guys. That's what I originally had shot for, but I pushed that test to another day. But y'all, that test shouldn't take long at all. Okay, so I may move it back up. I'll just have to see.